Today we are going to review how to find equivalent fractions when given models or visual aids, or even when it's placed in some sort of a word problem. So some of our examples are this first problem here. Penelope ran a fraction of a mile. The part that is not shaded in this mile shows how far Penelope ran. Which model below is shaded to show a decimal equivalent to the fraction above? So the first thing we need to do is look at the model that they're giving us. The part that is not shaded shows how far Penelope ran. So let's count how much is not shaded. 1, 2, 3. 3 are not shaded. Now we have to remember what our denominator would be is our total amount. 1, 2, 3, 4, 5. So that is 3/5. Then we need to come down here and interpret all of the models. So we've got 1, 2, 3, 4, 5, 6 longs, which is 6/10. Then we can come over here to the next one. 1, 2, 3, 4. 4 longs is 4/10. 1, 2 longs, so that's 20/10, or 20. 21, 22, 23, 24, 25. So that's 25/100. And then we have 2/10. Now we've been working on how to relate decimals to fractions. So we can remember our base 10 equivalencies, or we could also remember our decimal equivalencies, but if neither of those two strategies are working for you, convert all your decimals to fractions. So this would be 6/10. This would be 4/10. This is 25/100. And this is 2/10. Now that we've got all fractions, we can compare and find equivalent fractions. And our strategy that we've been working on to find equivalent fractions is using the butterfly. So let's go ahead and put our 3/5 and let's butterfly it to 6/10. That would be 30. And 5 times 6 is 30. So right away we know this one is equivalent. Let's try the next one. If 3/5 and 4/10. Well, if 6/10 was equivalent, will 4/10 be equivalent? Probably not, because they have different numerators, but let's just double check. 30, 20. Nope, 3/5 is greater than 4/10, because 30 is greater than 20. 3/5. This would be 300. And this would be 125. So again, 3/5 is greater than 25/100. 300 greater than 125. And again, if 6/10 is equivalent to 3/10, 2/10 should not be, but we again can double check. 30 is greater than 10. So the only answer that's equivalent is this first one. 6/10 is equivalent to 3/5. Now we can go to our next problem, in which we are given 2 fractions. And again, all we can need to do on this one is butterfly them out to find which one is equivalent. 18, 18. 30, 40. 28, 24, 12, and 24. So which numbers are equivalent? A. 18 equals 18. 30 is less than 40, 28 is bigger than 24, and 12 is less than 24. And our last type of problem is where we have a number line visual, and then we have a lot of different models that we have to find equivalency for. So let's go ahead and look at our number line. We always start at 0. 1, 2, 3, 4, 5, 6, 7, 8. So I know my denominator is going to be 8. Now I need to find out where A is. 0, 1, 2, 3, 4, 5, 6. 6/8. So then I need to come down and figure out which one of these models equals 6/8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 6/8. So that one equals 1, 2, 3, 4, 5, 6, 7, 8 twelfths. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3 fourths. And this one, as I know from my visual that I've been working with all year long, if I break this into quadrants, that is also 3/4. So let's butterfly out 8/12 and 6/8. And 12 times 6, that's a thinker. 12 times 6, 72. 8 times 8, 64. So not equal, greater than. So if this is not equal, is this 8/12 equal? No. So then again, 3/4 and 6/8. 24, 8 times 3, 24. 24 is equal to 24, so this one's equal. So if this 3/4 is equal, so is this 3/4. And those are the three different types of problems that you could see that include equivalent fractions.